Hey everyone, Max here. Today we're going to talk about the chi-squared distribution. That is the chi-squared distribution. And the chi-squared, some people say chi-squared. Don't say that. You'll sound like an idiot. There's no kinder way to say that. But largely because there's also fraternities on campus and they have Sigma Chi. So you should at least know how to say chi. Chi is represented as kind of that curly X, okay? And so the chi-squared distribution, of course, is represented by a chi-squared. And we put a degrees of freedom. Now, the technical formulation for a chi-squared distribution is actually going to be the summation from I equals 1 to nu just matching right here, the degrees of freedom, zi, where z is distributed as a normal 0, 1, and they're all squared. So basically, you can take these random variables we've been working with, and with some fancy mathematics, you can essentially perform arithmetic. Now, the arithmetic on random variables is much different than the arithmetic you're familiar with, but these are details you don't necessarily need to concern yourself with. All you need to know is that the chi-squared distribution is the result of summing some distributions, okay? And for this reason, a chi-squared of 0 degrees of freedom does not exist. Because that's saying you have a summation of nothing. So if you have a summation of nothing, then literally nothing exists. So you can never end up with 0 degrees of freedom. Degrees of freedom being abbreviated DF. And so this ZI here and this Z here, these should be fairly familiar. The only thing new right here should be this chi-squared. And so if you want some pictures of what a chi-squared looks like, is it ranges. So when you have a chi-squared of 1 degrees of freedom, it looks like that. When you have about 2, it looks like that. And as the degrees of freedom increase, it looks more and more normal. So that is chi-squared of nu degrees of freedom as nu increases to infinity, so it gets really big. Even before 100, but 100 is pretty safe. Chi-squared distribution will approach a normal distribution. Okay, and this is a result of various things going on in mathematics, but it's one important thing to note that if you have a really large degrees of freedom, then you can essentially compare this thing to a normal distribution. And now, what we're going to do in for the chi-squared test is we're going to work with something called contingency tables. Okay. So this is I have a friend who is a geneticist, and he he doesn't work as a geneticist. He has a PhD in genetics from Berkeley, though. He actually used contingency tables all the time. So I know it's heavily used in genetics. I would go so far as to argue that it's heavily used in the biological sciences, and this is because contingency tables can help determine independence and can help determine the fit of a distribution. We'll talk about both of these more later when we go through some examples. But the big thing that you should know is that we can test for independence. So I'm going to just move that a little. This test of best fit. Right, so you're going to hear these things referred to as a few things, but essentially you're performing the same test each time. Sorry, what I'm trying to say is that the chi-squared test is quite versatile. And if you essentially want to use it for determining independence, you're going to use the same test as you would if you were determining the best fit of a distribution. You're just going to be thinking about it differently. That is, chi-squared can be used in many ways. It all depends on interpretation. Okay, and just before we end this little introduction to the chi-squared, because that's really all there is to it, is that you can also see things written like chi-squared of nu, or you can see chi-squared, I believe, in the notes of k. So you could also see chi-squared of k. And when we're dealing with these contingency tables, we'll go through examples in the next video, because I'm trying to separate these out. You'll essentially have, this will be a total, this will be a total. You'll have some categories here. You'll essentially have some data here. And what you'll do basically is just compute a statistic for each of these things. And then you'll just multiply them and add them all up, and then you'll have a test statistic value and you'll compare it to a table. And because we're moving more to an online format, I'm going to go over the examples in the notes and show you how you would compute this by hand. But note that Excel and other software will very easily compute a chi-square test for you. It's just in order to use the Excel functions, you have to understand what you're actually trying to do. Okay, so that's the chi-square distribution.